So as you can imagine, there's going to be a relationship between how hard you're pushing electrons, how much opposition you're getting to the pushing of the electrons, and that's going to determine how fast you can push electrons for your current. Okay, so these variables are related, and they're related by Ohm's law. Okay, and we're going to take into consideration first what we call DC electronics, direct current electronics. So these are voltage sources that are not oscillating or varying. They're just straight out voltage sources. Okay, and when we're dealing with DC electronics, the opposition to flow is primarily through resistance. Capacitive reactance and inductive reactance typically are not issues in DC electronics, but 99.9% of what you're dealing with is not DC electronics, but this is a nice introduction. Okay, so in DC electronics, Ohm's law, the amount of force that you can pass is equal to the current times the resistance. So the force is equal to the current times the resistance. And you can manipulate any two to control the third. So if I want to pass more current into the brain, for example, I can either increase the force or I can reduce the resistance. Okay? If I want to decrease the force that I'm pushing on to the neurons, I can do that by changing the current, reducing the current, or decreasing the resistance. Okay? So the force, the voltage, is equal to the current in amps times the resistance in ohms.